Let's take a look at this equation that we're given here on the left hand side. X squared plus 4x minus 6y plus z squared equals negative y squared plus 3. And take a look at this point over here, 6 comma 4 comma root 2. So of course, based on the x, y, z and the 3 coordinates over here, this is a 3D question. And what we're asked to do is find the minimum and maximum distances between whatever figure this is. We're going to have to figure out what that is. Figure out the distance between that and this point right over here. So let's start by trying to get this into a more recognizable form, because it's not super easy to see what this is right now. And to do that, we can kind of bring all the like terms onto one side. And when I say like terms, I just mean all the terms with variables onto one side. So we're going to add y squared to both sides. That's going to give us x squared plus 4x minus 6y plus z squared plus y squared. Over here, since we added y squared, that's going to just go away, and we're left with 3. What we now want to do is kind of bring the y squared in front so that it's just a little neater to see. And another step we're going to take is actually completing the squares, right? This is probably something you've done if you've ever dealt with quadratics in the past. And it's a very, very similar process that we're going to follow. So for x squared and 4x, that's going to be x plus 2 whole squared. But that gives us an extra 4. So we need to subtract that off to keep everything equal. Here we now have y squared minus 6y, so that's y minus 3 whole squared. Then we subtract off a 9. And then the z squared is pretty easy to deal with. You just put that as it is. This is equal to 3. We need to get rid of the negative 4 and the negative 9. Easiest way to do that is to add 4 and 9 to both sides. So we add 13 to both sides. So the left hand side is now x plus 2 whole squared plus y minus 3 whole squared plus z squared. Right hand side is 3 plus 13, which is 16, and we're going to write that as 4 squared. You'll see why in a moment. Okay, what does this look like? Well, hopefully you recognize this. This is just the equation of a sphere. It's very similar to the equation of a circle. So if you just remove the z squared, for example, and that's actually called taking the trace of this 3D shape. If you just remove the z squared, this is clearly the equation of a circle, right? If you remove the y minus 3 whole squared, this is the equation of a circle on the xy plane. So it's a sphere, and all the x plus 2 and y minus 3 say is at the center. So the center is going to be at negative 2, 3, 0. The radius is given by this over here, very similar to the equation of a circle. So that's why I wrote it as 4 squared. The radius is 4. Okay, now let's go back to the question over here. How can you find the minimum and maximum distance between this equation and this point over here? So let's draw it out, and it's going to be pretty difficult to draw in 3 dimensions, especially on this software. So I want to do 2 things. First, I want to write down that point again because it's off screen right now, and I will need it later, of course. So this is the point in question. And now I'm going to kind of sketch it out, right? Just a conceptual drawing. I'm not even going to make the points anywhere near realistic. Let's say this is a sphere. This is the center of the sphere. And let's say our point is off over there. The minimum distance. Well, the minimum distance is going to be this distance right over here, right? And you can see that because that's going to be tangent. So you want to go from the center of the circle to that point, and then you remove whatever is this distance, which is just a radius, which is just a radius of the circle. So to recap that, it's just the distance formula between the center and the given point, the point in question, and then you subtract off the radius. That's going to give you the shortest distance. And if you want, you can try to prove this and see, but hopefully you can tell that just from intuition. What about the longest distance? Very, very similar process. Instead of subtracting the radius, you're going to add on that radius and go all the way opposite. So the other side of the circle, of the sphere from where we started. And that's going to be our longest distance. So the shortest distance, the minimum, is going to be distance d minus r. And the maximum is going to be distance plus r, right? Distance is from here to here. That is d. This is r. This is r. Okay, I'll get rid of that now so you can just see our drawing there. Now let's find d. We already know r is 4, so all we need to do is find d. That's just the distance between these two. Distance formula in 3 dimensions. Okay, so 6 and negative 2. 6 minus negative 2 is 8. 4 minus 3 is 1. Root 2 minus 0 is root 2. So this gives us the square root of 64 plus 1 plus 2, which is the square root of 67. That's it. We've got D. We know that R is 4. So the minimum distance has to be root 67 minus 4. If you want to estimate that, this is just a little bit above 8. So this minimum distance is going to be like 4 point something. And the maximum distance is going to be 8 more than that, because instead of subtracting 4, you're adding 4. So this will be a little bit over 12. So let's call this like roughly what, like 4.1 maybe. And then this will be approximately 12.1. Those might be off, might be something else, but that's just a rough estimate. And with that, we're done. So the question, it's mainly just figuring out what this looks like and then working from there. We got very lucky with the fact that it's a sphere. Otherwise, like if it was something like a hyperbola of 2 sheets, for example, that would make things a lot trickier. Luckily, though, it's just a sphere, and then all you need to do is really make this observation and kind of get these expressions, d minus r and d plus r, and then work from there. But it's not a very difficult question. I hope you enjoyed and learned something new. Thanks so much for watching.